Well, welcome everybody. It is now the appointed hour. So welcome to the second session of this week's webinar, which is going to be the impact of improper maintenance practices. So it's nice to see that there are some new people that are attending the webinars, as well as some regulars. So for the regulars, thank you very much for attending, as always. Normally, for the new people, we will little introduction on exida and who we are. So I'll just give a brief overview, and those of you that have heard this many times before, sorry, but if you could just bear with me, I'll keep it as brief as possible. So exida has been around for 20 years. It was originally started by two founding members, and the reason they did start the company was because they were trying to help manufacturers understand what was required from this new standard that had been released, which of course was IEC 61508 in 2000. The first draft had come out in 98 and the actual release was 2000. And since then, we've grown exponentially from not just doing product certification. Now we do functional safety product certification and cybersecurity product certification, but also to doing personnel certification. Some of you are CFSEs or CFSPs. Some of you may be thinking about becoming a CFSE or CFSP. If you are, then please visit the website and you'll find how to do that. Coupled with that, we've now provide services for 3 life cycles: the alarm management life cycle, the functional safety, and the cybersecurity. And the good thing about that is that we can be fairly industry agnostic in terms of the fact that we're not operating in any one industry, because these are requirements that are in the oil and gas, in the chemical, in the food and beverage, the pharmaceutical, steel, mining, any process or any application where there is a requirement for safety, cybersecurity, or alarm. So these days we're doing quite a lot of robotics, autonomous vehicles, so we get into the automotive as well. And to support all of that, we have a comprehensive set of software tools. And again, some of you are probably familiar with our Excellencia suite. You may even be using it. So we are global and we are expanding and adding offices all the time. We just recently, towards the end of last year, added another office in Ireland. The year before that, we added an office in Australia. And before that, we added an office in Mumbai. So we are continuing to expand even under COVID conditions. And that's mostly because companies still need to get work done, and therefore they still have requirements for support with functional safety, cybersecurity, and alarm management. How do we measure our success over the years? Well, we are actually the market leader in certification now. Practically 2 out of every 3 devices that are certified have probably been certified by exida. And we've also moved away from being just owned by 2 founding members to being mostly employee owned now. And that was deliberate on their part because they want the company to continue after they've retired. We now have well over 100 global experts. We also have over 1,000 certification and assessment projects under our belt, and our Excellencia tool has modeled well over 500,000 SIFs. Reference materials. Here again, we've published a lot of books. The latest one was the book I published, Functional Safety for Managers, What Managers Need to Know. That was last October, I believe. And we have Implementing IEC 62443, A Pragmatic Approach to Cybersecurity, and various other books that have been around for a while and very popular. And these you can obtain through the website if you so wish. The SERH is the Safe Equipment Reliability Handbook that has all the failure rates. This is effectively what is built into the Excellencia tool, so you don't have to go searching for specific manufacturers' failure rates or even generic failure rates. When I teach our FSC 100 class, I always encourage people to utilize our website because we do provide a lot of free information. And for example, there's what's known as the Safety Automation Equipment List, the SAEL. So when you go to exida.com, in the right-hand corner, you'll see that SAEL. And when you click on that, you can then go and look for certified devices. And you can search under different types of devices, such as actuators, logic solvers, valves, etc. And that's all free. So if you're trying to do a design, a SIF design, and you need to look for some certified equipment, that's a good place to start. And you'll be able to pick from the website the certificate, so you can see the failure rates on page 2. And if we're allowed to publish it, you'll see the assessment report, which tells you how we came up with the numbers. These webinars are also recorded, and they're all available through the website. If you go to the resources tab on the website, you can look at webinars, you can see which ones are coming up. Then you can also go and look at the archived webinars. And here again, they're categorized. So there's webinars under product certification for cybersecurity and for functional safety. There's webinars on personnel certification. There's webinars on functional safety, alarm management, and cybersecurity. So you'll probably find a webinar on something that of interest to you. And as I said, those are all free. I'm not going to say too much about me. I've been around for quite a while now in industry. My role at EXTER is quite varied. I'm responsible for the end user business, and I also teach the FSC 100, which is our functional safety class and our cybersecurity class. So let's get to the meat of this. Impact of improper maintenance practices. Well, we still have issues with end users not performing maintenance the way they should perform the maintenance. And it's very important from the safety instrumented system point of view, because even though we go through all the rigor of making sure we identify the hazards that we need to protect against, we identify the layers of protection that we have, we identify the layers of protection we need, and if there are safety instrumented functions, we need a safety instrumented system, and so we develop all of that. We do all the validation, and then we start up. Well, it doesn't just end there. Yes, that's when we start up from the zero time, if you like, the system is exactly as we intended it to be, the safety instrumented system and its safety instrumented functions. However, if we do not follow the requirements of the SRS in terms of the testing and everything else, we will have problems, and you could end up with very serious consequences. So what does it mean to have good maintenance practices, for example? So what we should be doing is looking at how well we carry out our mechanical integrity and our maintenance and repair. Now, it's been shown that in some accidents, some end users simply went through the motions, check the box, tick the box if you like, without really doing all the necessary repairs. Even now, I still come across clients that are having a run to fail policy for their equipment, including the SIS equipment. So the SIS is very, very special because effectively it is our last line of automatic defense. And we want the safety instrumented system and the safety instrumented functions to operate when required. So this means also that we have to ensure that our people are properly trained and that procedures are in place. And here again, when I teach the FSC 100 class, I talk about the systematic issues. These are issues that are insidious and can only be removed by a change in the design or training or procedures, what I term the 3 Ps. So P1, the first P, is people. Are our people properly trained and competent? And the change in the 2016 edition of 1511 was to put far more emphasis on roles and responsibilities and competencies. Because again, this is something that's not been done very well. The second P is procedures. Do we have written procedures that are actually being followed? Here again, the CSB has lots of examples of accidents where startup procedures were violated or maintenance procedures were violated. They weren't being followed. So again, if the procedure isn't being followed, then either change the procedure or get rid of it and have something else. And the third P is the paperwork. Do we have the paper trail to show that we're doing what we said we were going to do? Because if we don't, we could end up with problems occurring there. So this is the reason why we need to do this. The next question is, how do you know how good your practices are? And here again, when I talk to companies, a lot of the managers feel that they are following good practices, but they're not necessarily measuring it. So one of the things that you can use that we have come up with as exida is something called the Site Safety Index model. It's a way of doing a qualitative first pass, if you like, at assessing the capability. It's basically a questionnaire. So you can go to the Site Safety Index website and fill in the questionnaire. If you fill it in honestly, it'll give you a ranking. The other way to do that is to follow up with an independent third-party site audit, where somebody comes in and does a series of interviews to see how things are being done. Being able to measure the SSI is obviously very important in terms of understanding where the company currently is and what improvements can be made. So what is this model? It is basically a simple qualitative model using concepts from 1508. So somebody said to me this morning, well, where is it in 1508? Well, it's not. It's what we have determined from the concepts of 1508, and we have built this into our tools so that you can look at how well maintenance is conducted. And you can look at it from the sensor subsystem, the logic solver subsystem, or the final element subsystem. And as you can see, there are 5 levels, 0 to 4. 4 is perfect. That means everything's done on time according to requirements and nothing is missed. 0 is bare minimum. That repairs are not always done when they need to be done, or they're not fully complete. There's some sort of band-aid that's been done to just get them by. These are things that would cause a degradation into the performance of the SIFs, your safety instrumented functions. So you may think that you've got a SIL2 SIF, but if you're not maintaining it properly and you're not doing the proof testing according to requirements, so here again, it's important that the safety requirement specification is with the operations and maintenance people. If you don't know what's in that SRS, how are you going to be able to maintain the safety instrumented system and its safety instrumented functions properly? So again, with the tool that we have, we usually give the benefit of the doubt and default to an SSI2, which means good. And if you do have Excellencia, you can try it yourself. You can, for example, look at the final elements and change it from good to 0 and see what it does to the risk reduction offered by the SIF. And you'll be very surprised. It has a significant impact. So why is it important? Well, people shouldn't need to really ask this question, but it's true, it still happens. Why is it important? Well, it's important because it could save you having a serious incident, or worse still, a major accident. And again, Macondo, as you see in that picture, the latest estimates for that one accident is 62 billion. So one accident. So there are lots of examples, and some of it can come down to a poor site safety culture. So what do I mean by that? Well, culture is very endemic in a company, and it usually comes from the top down. So if the company board is only focused on the bottom line and keeping their shareholders happy and minimizing costs, that's not going to help when we're trying to maintain the SIS and its SIFs. So if you went to your manager and said, look, I need to raise a purchase order to have these devices replaced because they're becoming at the end of their useful life, or I need to spend X thousand dollars to have these valves refurbished. And he says, well, have they failed? And of course, the answer is no. The pushback may be, well, then why do we need to do that? So this is another area where we are trying to help educate end users by explaining to management, if they don't understand, why these things are important. And interestingly, and I should have made this point this morning, is that insurance companies are paying attention to all this now. And they're having their assessors come on our webinars. In fact, I've done a series of webinars for a couple of the insurance companies for them to understand the questions they need to ask their clients when it comes to functional safety and cybersecurity, and indeed alarm management. So it's very important to have the right culture. Some of the factors that can impact the safety instrument system and the overall performance, of course, is that the equipment selection and qualification. So when the design is being done, it's very important to look at the requirements for the equipment. And whatever equipment is chosen, 1511 is very clear about how you justify the choice of the equipment you're using in your safety instrumented function design. The first is to use IEC 61508 certified devices for the relevant SIL level. The second is prior use justification. That is it. Because I like the equipment, because I'm used to the equipment, doesn't qualify. Prior use justification requires that you have considerable amount of accurate data, failure data, on the devices you're using in similar operating profiles and environments. Now, it doesn't necessarily have to be in a safety application, because function-wise, they're operating the same way, whether it's safety or non-safety. So if you've been using it in normal non-safety, as long as the data is sufficiently voluminous, so in other words, we have a high number of operating hours of data, so from a statistic point of view, it's valid, and it's applicable to the environment and the conditions, then we can use that data. If not, it's going to be very difficult to justify the prior use application. And the purpose of the prior use justification is to prove that we don't have potential systematic issues, that the systematic problems are down to a low enough and acceptable level. So in other words, when we're looking at the data, the failure rate data, it has to be classified properly so that we can see if the failures were safe or dangerous. And of course, it's the dangerous failures that we're worried about. So equipment selection is very important to make sure we do that right. And here again, when I teach the class, I tend to refer to RTFM, read the flaming manual, which means you need the safety manual. So for the devices you are intending to use, you need to make sure you look at the safety manual. Because, for example, if you have a SIL 2 requirement for a device, and the safety manual says, well, the device is SIL 2 capable. There's that lovely word capable. What does that mean? The safety manual may say, well, you need 2 of them and they have to be configured this way. If you don't have the safety manual, and we actually had this, we had a client come to us for a SIL verification. And when we looked at it, we said, well, it's no point us doing the SIL verification because it's going to fail. And he said, well, why? It's a SIL 2. And we said, no, it's a SIL 2 capable, and you need 2 of them, you've only got 1. So the safety manual is very important for a number of reasons, because it will have installation, information in there. It'll have a recommended proof test to achieve a proof test coverage. It'll have any restrictions on use and any requirements to achieve the SIL. So you need to have those safety manuals. Now here again, 1508 says the manufacturer has to supply a safety manual, but doesn't say he has to supply it free of charge. So you may find that if you want the safety manual, you may have to pay for it. But it's very important that the end users, the operation and maintenance people, have access to those safety manuals and the SRS. The other thing that will affect it, the performance of the SIS, will be how it was commissioned and tested. So again, if we don't have the safety manuals when we're doing the installation, we may not configure the devices correctly. So for example, let's say during SIL verification, we were using smart transmitters and we were taking credit for the diagnostics in the calculation. But because the installation people didn't have the safety manual, they didn't know that they had to enable the diagnostics. So now we're running our system with its SIFs, thinking that we're good because we've got diagnostic coverage, and all along the diagnostics are not doing anything because we haven't configured them. So that's another thing to look out for. The safety validation test. This is very important because what we do here is to make sure the as designed, installed and commissioned SIS and all its safety instrumented functions meet all of the requirements of the SRS, and that will include all the timing as well as making sure that the SILs are correct. So if we don't do that right, and typically that should, if there are problems with validation, it should be picked up during the FSA 3, which is the pre-startup safety review. And we should find it there. Proof test procedures. Here again, we should have all our proof test procedures in place before we start up, and it should be available to the O&M people. Proof test procedures can come from a couple of sources. It can come from the safety manual, or it can come from the experience of using the equipment. And indeed, if you're using Excellencia, Excellencia looks at the equipment you've selected for the SIF and will come up with a proof test based upon the manufacturer's recommended proof test for the devices you've selected. So it sort of does the job for you. Failure diagnostic and repair procedures. Like I said, if we're using diagnostics and we do get a diagnostic alert, where does it go? Who sees it? Is it supposed to be in the maintenance cabin? Because again, if we're not doing that right, we might not see the problem before we get a demand, and then we suddenly find we've got a failure on demand because the diagnostic wasn't being tracked properly. Repair procedures rather. These need to be in place because here again, when we do the design and the SIL verification, it's based upon a mean time to restore. So basically, you have to set a time from detecting we have a problem to fixing the problem to getting the SIF back up and running. We need to define what that time is. And typically we might say it's 24 hours or 72 hours for final elements, as an example. So that means that we have, SIF will be out of commission for either 24 hours or 72 hours. And we may have to take alternate steps whilst it's out. Device useful life tracking. This is very, very important because once the device gets outside of its useful life, it's in what we call the wear out phase, where it's highly unpredictable. Also, all our PFD average calculations or our PFH calculations using random failure rates is predicated on one simple concept, which is constant failure rate during useful life. In other words, the flat portion of the bathtub curve. Now, if you want to know more about that, I've done a webinar on it, and I've also done a video on it, which you can find through the website. SIS modification procedures. Here again, we have to make sure, and the standard now requires us to do an FSA 5, which means that if we're going to make a change, to do a modification, that has to be properly assessed by somebody who is competent and responsible to do that. So they're looking at what's the impact on safety, and do we need to change the SRS as a result? SIS decommissioning as well, those procedures, because if we're going to take the SIS offline, how are we going to do that? Are we going to do it with the facility running? In which case, are we going to take a SIF offline at a time? And how are we going to manage that? So all of those things are very important. And of course, there are other things as well that will impact the performance of the SIS and its SIFs. So what are the consequences of improper maintenance? Well, the obvious one is that we could end up with SIFs failing on demand. This is something we want to avoid like the plague, because hopefully the SIFs never get called into action because our non-SIS layers of protection are doing their job. But if it is called into action, it needs to be reliable and work. We can also get an increase in unwanted trips. Here again, if we're not maintaining our equipment properly, we could get a lot more failures, premature failures. This will have an impact on maintenance because it's now going to increase the maintenance budget because we have to spend more money and more time fixing things or having to start up again. And of course, if we've had a trip, depending on what it is, if you've got a refinery and you trip the refinery, that's significant, because when you start up again, that's one of the highest risk activities you can do. Plus, it may take you the whole day to get the whole thing back up and running. So the cost of that can be significant. If it's 60,000 barrels a day, you lose a day's production. The increase in risk and the likelihood of a major accident will go up every minute of every hour of every day of every week of every month of every year. So if we're not doing proper maintenance, we're going to increase our risk. We're also going to increase the potential for serious injury or fatality as a result. I don't know about you, but I don't really want to play Russian roulette with 5 bullets. In a way, that's what we're doing. If we're not following proper maintenance of our SIS and its SIFs, we are increasing our risk all the time. And of course, then end-of-life devices are not refurbished or replaced. So that's another issue that will cause us to have problems with the performance of the SIS and its SIFs. Now let's remember that the whole purpose of IEC 61511, the standard, is to provide us with a means to reduce our risk. But more importantly, it's a performance-based standard. It's not prescriptive. So for example, the NFPA 85 is prescriptive. Double block and bleed, you've got no choice. Whereas with a performance-based standard, it'll say this is what you need to do, but how you do it's up to you. Also, because it's a performance-based standard, we need to have a means of being able to measure how we're doing. So we obviously have to come up with some performance indicators to be able to measure, to know how we're doing. And it's interesting that when we look at the life cycle, there's this one box that says operation and maintenance. And by the way, that's operation and maintenance is all covered under clause 16 in the standard. And this one box here is where we're going to spend 90% or 95% of our SIS lifetime. So we can do all the analysis correctly. We can design our SIS and all its SIFs correctly. We can have all the right SILs. Everything's hunky-dory. We're within our target. But if we're not following the operation and maintenance properly, we'll very soon degrade and not have the level of risk reduction and protection that we originally designed. So it's very important for us to track how we're doing. And therefore, we need to come up with a set of KPIs, key performance indicators. So we can use it to measure the effectiveness of the SIS and its SIFs in terms of doing its job of risk reduction. One way of doing it is you can use some leading and lagging indicators. And I did another webinar on this as well, which is in the archives if you're interested. But fundamentally, leading indicators are indicators that will give us an idea as to whether or not we're likely to have a problem in the future, such as we're not doing regular assessments of our O&M people. We're not making sure they're maintaining their level of knowledge and skill. People leave, we bring in new people, we don't train them properly, but we expect them to be able to perform. Unreasonable. So if we're not doing that, that's an indication that we're likely to have a problem later on. Procedures not being followed, that's another one. Proof testing. If we're not doing the proof testing according to the requirements of the SRS, this can also be a major problem, especially if we get outside of 10%. Because if the proof test intervals have been set at 18 months and we miss them by a couple of weeks, okay, that's not a huge deal, but we would want to see if we could improve that. Conversely, if we miss it by 2 or 3 months, now this is a big deal because it's going to have a big impact on the safety integrity of the SIF and how much risk reduction it's providing. So those are leading indicators, and that will tell us that if we continue doing that, we're going to have a problem. Lagging indicators are things that have already occurred. So for example, near misses. If relief valves go off, that's a sign that all is not well, and we should be looking at that and trying to reduce the number of times that happens. If we're getting a lot of spurious trips, why are we getting spurious trips? Is it the equipment? Is it the people? What's causing that? And of course, if we've had incidents and demands on the SIFs, whether they're real or not. So all of those should be counted, and then what we want to do is see how we can reduce them. So those are lagging indicators. I mentioned culture already, but this cannot be overstated. We really need to have the right culture. If the culture's not there, it's going to be very difficult for the people who are responsible for maintaining the safety instrumented system to be able to do it without continually battling with management for funding. Management has to buy in and support this process. So this means we need to develop a learning culture, an open and learning culture. So that means that we have to be willing to do things right and also doing the right things. We learn from mistakes, we don't punish, we encourage, we want people to take responsibility, we want them to have some ownership. So making sure people are properly trained, making sure that procedures are being followed, conducting audits. And I say to managers, you can do your bit simply by walking around, talking to people, seeing what's going on, and reading any of the audit reports that are being done. Because if you see that there's a trend going in the wrong direction, then that needs to be corrected as soon as possible. And of course, if we do this right, it actually saves us time and money. Because if we're not having to restart because we've had a trip due to a failed piece of equipment or somebody making a mistake, that will save us time and money. Now, the other thing is 1511 was changed in 2016, as most of you know, and one of the requirements now is to do the FSA4. And it's interesting that some countries, and Australia is one of them, does insist on FSA4s being done. So the regulatory control is much stronger. And also in Europe, in some countries in Europe and elsewhere. But over here in the US, this doesn't seem to be done very much. And it's a shame because the standard says you need to do it. It doesn't tell you how often you need to do it. That's something that you can define yourself, and you can do it based upon experience. If you're getting incidents and trips and near misses, then that should be an indication that you need to dig in and start looking at what's going on. If the performance is good and we're not having any issues and problems, you could probably do it every 2 or 3 years. But the way to look at it is every 5 years we have to revalidate the PHA. So, and do the hazard and risk assessment again. And that's a good period of time to be gathering information. So the information you gather, and from the FSA4, you can feed into the HAZOP team. So you can look at the assumed demand rates. Were they the same? Are they still the same? Or do we need to reconsider? So what needs to be measured? Well, we define the proof test intervals, as I've said, and those are used in the SIL verification calculation to prove that the SIF design meets the target SIL and the risk reduction. So how frequently does it need to be done? We need the SRS. We need to follow that. Is it being performed on time? As I said, as long as you're not going over 10%, even then, up to 10% is still going to have an impact. But if it's more than 10%, it's going to get worse very quickly. Then are the proof tests as effective as originally intended? So here again, are we following the proof test procedures? Because you can design the best proof test in the world, and let's say you can get 95% coverage, but if it's going to take 10 hours to do the proof test, well, guess what? It's not going to get done the way it was intended. So the effectiveness is not going to be there. And again, that has an impact on the performance of the SIF. The O&M personnel assessments. So are we conducting the training? How often are we doing it? The standard says it needs to be done periodically. Again, it doesn't tell you what that period of time is, but it needs to be defined. So we've talked about demands on the SIS, whether they're real or false. So we should be counting those, and we should be making sure that they're within the required limits. If not, we need to do some investigation. Incidents and near misses, as I've said already. Failures, both random and systematic. So if we've got some systematic failures because, let's say, an instrument tech miscalibrated a trip point on a piece of safety equipment such that it would be in a dangerous situation because it would never reach the trip point. So that would be a systematic, because it's either he's not been trained properly or it's because the procedure may be wrong. That could be a systematic, but it needs to be looked at. Random failures are failures that typically relate to hardware, but could be people, because people can make random mistakes as well. And that's why it's important to make sure that you understand the type of failure, because when we do the revalidation for the SIFs using field data, it's all based upon random failures. So if we haven't been documenting our failures correctly, we could have optimistically low random failure rates that we're trying to use. Proof testing, as I've mentioned already. Repair and restore times, the mean time to restore needs to be followed per the SRS. And as I said, if it's 24 hours or 72 hours for final elements, we should be running that, monitoring that rather. And the maximum permitted repair times. Now it's interesting that the standard says you need to define a maximum permitted repair time. So here again, it's if you're going to leave the SIF in bypass or if you're going to take it out of service, there needs to be a certain maximum period of time that you're allowed to do that for without going back and seeing why. So for example, if we set our 72, we might say, well, given that we might have some delays in getting the parts we need or being able to refurbish, let's make it 100 hours, just as an example. And then we can track that. We can see if we're extended beyond that. And of course, procedures not being followed properly. So we can feed this back into our 5-year PHA revalidation, and we can look and see also whether our test intervals are still valid or whether they can be extended. So if we're finding that our performance is better than first assumed during the design, then we can maybe extend the proof test intervals, which will save money on maintenance. It also enables us to confirm any assumptions that were made originally on the demand rates and the hazard frequencies. And remember, the hazard frequencies are different from the demand rates, because if the non-SIS layers of protection are doing their job, the SIF should never see a demand. So we can compare our actual performance with our assumed performance. And the way we can look at this is the risk reduction that we have adequate? If it is, we can continue collecting our data. If it's not, if it's inadequate, then in terms of the hazard risk being higher than expected, then we'd obviously need to go back to the analysis phase and think again. If there's an over-design situation, in fact, we've got more than adequate, then we could look at a modification of the design practices. So the idea being that we could change the proof test interval, we could look at maybe we could drop a SIL level if we don't need it. But in all cases, we collect the data, we use the data to learn any lessons from operations, and then we feed it back into future analysis. That's the whole point. So let's just sum all this up then. So the main thing is to make sure that we have an appropriate safety first culture. So we do have trained and competent O&M personnel, and that our site practices are good or better than normal. We don't want to have SSI 0 or SSI 1. We want to be at least 3 or ideally at 4. We want to make sure that we have proper operating and maintenance procedures in place. And again, we should be tracking that to make sure they're being followed. You can use checklists. I'm a great exponent of checklists. I always use my pilot's analogy. You can have a commercial pilot that may have flown thousands of hours, but every time he gets into the cockpit, he doesn't rely on his memory or his experience. He goes through his pre-flight safety checklist to make sure he hasn't missed anything. And as I mentioned already, you can develop and maintain leading and lagging indicators to help you with that. You can also undertake regular competency assessments. So how you do that, again, is entirely up to you, whether it's a supervisor monitoring what one of the O&M guys is doing, whether it's maintenance, whether it's operations. You can do it any number of ways, but you just need to do it and you need to document it. Make sure that the proof testing is done in line with the SRS. If you don't have the SRS, then it needs to be found, because that is, it's not a once and done. It's not, let's do it and stick it on a shelf. It's a live document. It needs to be followed. And all the maintenance activities need to be accurately and faithfully recorded. So you can use software tools to do that in the recording and auditing. And we have one that goes with Excellencia. So if you've done your design in Excellencia and you've done the SIL verification, you can export the detailed design information, which is of course the devices, any tags, references, and the proof tests, into the SILstat tool that can be used in the field. So you can take a tablet out in the field, you can record the as found conditions before you do a proof test, and that can include a visual inspection. You can run through the proof test and record the results, and then record the as left, and that's immediately posted back up to a central server and is available to the asset management system or whatever else. Then you can use the tools to help you analyze the failures and look at any false trips and help us to monitor our overall SIS performance. We need to make sure that we continue with the proper maintenance throughout the life of the SIS and its SIFs. Hopefully you've understood that from the previous slides, because if we don't, we're just basically potentially on a ticking time bomb, and sooner or later the luck may run out. And you've only got to go to the CSB website and see how many incidents there are of explosions, fires, releases. It's still much too much. Alrighty, so just to let you know, we have some courses coming up which are online live streaming. So that means there's an instructor that will be presenting the class, and he'll be available to answer questions in real time, remotely of course. So there are some alarm classes coming up. There's the cybersecurity for integrators and solution providers coming up. The FSE 100, which is the functional safety analysis, design and operations one, which I'll be doing in March, and then the SIL verification with Excellencia. If you want to know more, you can follow us on all the social media, and of course, If you've got a suggestion for a webinar topic, please feel free to send it to academy@exida.com and we'll certainly look at it. And again, if you've got any further questions beyond today, then feel free to email me. So let's see what questions we have. We've got quite a few, that's good. For this qualitative SSI to be effective, the operating company needs to have an auditor ask these questions of the operating organization to avoid bias and or ignorance. Well, that's a very good question because, yes, obviously, that's why I said you can do it one of two ways. You can go to the SSI website and take the test, the Site Safety Index website. You can, it's not really a test, it's a questionnaire. You can fill in the questionnaire, and obviously if it's filled in honestly, then you'll get an honest result. But then what we say is it's worth following it up with an independent site audit so that there is no bias. And that way you will get a very good view. It was very interesting. I was presenting to a company where we had management, we had operations, we had maintenance, we had engineering. And I asked this question. I said, so where do you guys think you are in all of this? And immediately the manager said, oh yeah, we're up at 4. And then the rest of them started laughing and said, well, actually, we're lucky if we get to 2. And of course, that created quite a heated discussion amongst them as to why that was. But that's true. You can obviously have different views and opinions. So it's always better to have an unbiased opinion if you can. And we've done that for several clients. Is there any governing standard guideline that qualifies the instrument electrical device to be listed as proven in use? The simple answer to that is no, there isn't anything in the standard gives some guidance, but what we've found is that people get confused with that. We have our approach that we use for helping with the prior use justification. And if you want to know more about that, drop me a line, I'll be happy to tell you. Data specified in the safety manual by the manufacturer is bench tested and not specific to real-time installation and site challenge. Does one need to account a safe factor while considering that data? If yes, what is the standard thumb rule? Well, here again, it depends on how it's been done. When we do the FMEDAs, for example, failure mode effects diagnostic analysis for the device, we look at the operating environment conditions. So is it going to be severe service? Is it going to be clean service? Is it going to be offshore? Is it going to be subsea? Is it going to be in the desert? And so on. So yes, you have to take into consideration some of that. But again, the data specified there is the failure rates. I assume that's what you're talking about. Then you can, I mean, in the old days, we used to have a safe failure fraction that was used under root 1H, but that unfortunately got misused. So now there's the 2H with the 90% plus accuracy of the data. So site, I mean, we always tell people that the best place to get the data is from the site itself. But the trouble is, unfortunately, many end users' systems are not consistent for capturing the site data. For example, how they classify failures, whether they write them off as being systematic and just don't log them. And here again, the rule of thumb that I tell my classes, assume everything is random until proven otherwise. So what do I mean by that? Well, let's say we had a failure of manufacturer X's sensor in SIF number 2. And then 3 months later, the same manufacturer's sensor in another SIF number 23, also failed. Now we would log those as random, but then we'd say, well, hang on a minute, we've had 2 devices from the same manufacturer fail in a short time. That might be worthy of looking further into it. Are we using the device correctly? Is it rated for the environment correctly? Are we maintaining it correctly? So there could be some potential systematic coming from it, but this way we don't lose them. We record them as random. Culture absolutely has to come, from the top. Yes, that's true. And that's one of the chapters in my book, Functional Safety for Managers. I go into why culture is so important. What is culture? What does it mean? So yes, I fully support that. Do you know whether SSI will be part of the third edition of 1508? I don't know. 1508 doesn't call it that. As I said, we developed it. So whether or not it's decided to be used by the committee, I don't know. But anyway, it's a good question. And unfortunately, I see he's left, so I'll have to email him. Well, thanks everybody. I know it's getting late in the day, but I do appreciate the questions. I appreciate the attendance. I look forward to you joining a future webinar. And as always, I welcome feedback. If you found this useful, or if you didn't find it useful, if you think I can improve, please let me know. We're always looking for that. So thank you, everybody. Enjoy the rest of your day. Stay safe and healthy, and hopefully we'll get through this COVID at some point. Thanks a lot.